Good morning again. So this is from one of the books. Let me bring up the book from. This is our course outline. This is our course outline, and in the course outline, at the end of the course outline, I gave you references. The first one says 2 free books where you would get all the details of them. And the second list of references are books with code in GitHub. The actual books are not there, but I gave you the titles and the corresponding code examples of the book are located in the respective GitHub location. Here at this GitHub and the other GitHub, and the third example here. So each of these books, also the content, but the actual code are located on GitHub, so you can easily follow. So I'm going to use the second chapter of this book from GitHub in the second chapter. So that's what you see here. This is chapter 2, end-to-end machine learning project. This is a very good chapter, and you won't be missing. I will explain the details of the chapter. I have the book here. This is a book. I have access to this book through my company, and so this is the second edition. So we'll be discussing about this chapter, end-to-end machine learning project. So this is the second edition written in 2019, and the first chapter, the third edition is written a year ago, so in 2022. But we should be good using this content, except a few changes. We should be good using this chapter here. Okay, and since the notebook is publicly accessible, I have put this notebook under this folder. Under this Foundations of Machine Learning and Notebooks. So you will find the notebook that I'm using right here in this shared location. So under Notebooks in the Foundations of Machine Learning folder, Notebooks folder, and we have this one that we used last time, and this one that we used that we are going to use today. Okay. Let's go ahead and run. Let's see where we are at here. Sure. Okay. So we are going to use GitHub. Google Collaborator, and from this Google Collaborator, if you are running the code, I suggest you changing the runtime. The runtime is, I changed my runtime to GPU. So my runtime is a GPU runtime. So you have a non GPU, graphical processing units, or TPU, tensor processing units. Tensors are another ways of organizing, or just a format where we just a data format that Google developed to just like the way we have pandas, the panda data frame. So tensors are data containers, so just multi-dimensional data containers. So to process those kind of data sets and tensors, Google provides a tensor processing unit machines that are very optimized for tensor processing. GPU machines are very popular for and are optimized for processing and just a good performance machines for processing deep learning image and video audio related data sets for deep learning purpose, and they are faster, and the none of these two, so you could change. So how did I get to this place? You click on runtime, and then you come down here, change runtime type. Just you click on the change runtime, and where did I click? So you come down here and you click on runtime type, and then just a notebook setting will come. And for Python 3, we have obviously, and then just the other programming language supported on Google Collaborator is R, which is another programming language for data processing. Since we are using Python, I change this to Python. And TensorFlow, no, GPU, but the only support GPU types is T4. These are the machine types. The machine types A100 and V100 are very powerful machines, but I don't have access because I'm not paying. But when you pay, you get access to this, right? For our purpose, we should be good with T4 machines. Having said that about the machines, then just now my code is going to run on GPU, which is like just relatively a good performing machine, even more than what my laptop can do. My laptop. So this is on a cloud and freely available that you can do. And let's see where my execution is. I started this execution and see if it is done. Yes. Some part of the code is, so I started running this code, so I have to stop this execution, otherwise it won't be. Let me show you just what happens if I start running this simple cell. It will show me like run, and it doesn't finish. Oh, okay, so it finished, which means the last part was not updated. Okay. Queued at the 70 minutes ago. Okay. So it is queued, so we are fine. This is fine. Now, what we are going to do is we are going through some of the examples before directly jumping into the actual machine learning process. The actual machine learning process involves, collecting data, understanding the data, pre-processing the data, or transforming it, and actually executing the machine learning process. So the training the algorithm, the target algorithm. So what we are doing is the project is so it requires Python. So we are ensuring that Python 3.7 is available. Yes, and it also requires scikit-learn. Scikit-learn, as we discussed the last time, there are different frameworks or libraries that we can use for machine learning. One of the libraries, the popular libraries, is scikit-learn or sklearn. So this is the sklearn. And here we are importing sklearn, and then just ensure that we have so this assert statement checks the sklearn version to be greater than the version 1.0.1. But just to quickly check our version, we can simply say, if you remember last time, for any package in Python, the name of the package, you can use the following formula: package name dot. So this this gives you the version of the package, So scikit-learn is the name of the package. sklearn is the name of the package, which we imported right here, and just dot _version gives us this, which ensures that we have the right version here. Okay, so now the first step in machine learning is getting the data. So to get the data, we have to locate the data source, right? Locate the data source, and locating the data source for our particular scenario we have here, we wrote a method which says load housing data. This data is a California and district housing data. As you can see, your task is to predict median house values in Californian district given a number of features from this district. So just we have a data set, and we are going to locate that data set. And here it is. The path is data set, and the URL is here. This is where the actual the data set is located. It is publicly available in GitHub, and by the author of this book. So under this author's GitHub repository, we have it. And then just this method basically gets the data for us, and let's run the method. So we are basically just, if you see here, so this is a method that we used to load the data. So right, and now let's see the data, how the data looks like. So just the first step is loading the data, and the second step is taking a closer look at the data. So maybe one, finding the data, and second, taking a closer look at the data. So this is what we do. And so the methods to quickly check your data. So this is a pandas data frame. This is the housing is a data frame. You see, it is a data frame. And just the quick view shows us we have about 20,000 records with 10 different features. And now to quickly see, we have methods. The housing dot add or tail. So just you have the name of the data frame dot head or data frame dot tail will give you. So gives you the top 10, the top 5, or data frame. This one gives you the bottom 5 or 6. records depending upon, right? So now just let's run. So if you see these numbers, we said that, and the other one is, so the other thing is data frame dot shape gives you the dimension of the data. Dimension means number of rows and number of columns of the data. Number of rows and number of columns. Let's start with with dimension. The dimension. So the dimension is housing dot shape. I have to comment this to lines. Comment in Python is hash, and let's check the shape. As you can see, here we have, right? Housing dot shape is a method to check the dimension of the data set. The dimension, as I said here, the number of rows are 20,640, and the number of columns is 20. I mean 10. So so just let me write a new code so that you will get this, right? And the number of the top 5 records are like this: 0, 1, 2, 3, 4. All right, these are the 5 records, and the 10 columns are the longitude, latitude, the housing median age, total rooms, the total bedroom, population, households, median income, median house value, and the ocean proximity. So as you can see, almost all of the attributes or the columns are numerical data, numeric, except the last one, the ocean proximity, is categorical data. Numerical data means data or columns represented by a numerical value. And categorical means obviously values represented by either ordinal or nominal values. So those are categorical values. And if I change the method from head to tail, look at the index here. The index here for the head one starts from the top, 0, 1. So this is like Python given index to the data frame containing this data. So let me run the tail. The tail shows you the bottom indexes, Since the data starts from 0, the index starts from 0 for 20,640 for 0 rows. The index ends at 20,639 because the total number of records is this one, that one record. The reason why we have this 39 is because the first record is of index 0. Anyways, so now just additionally about the data set, we can also run this. The data frame, the name of the data frame dot info is a method that provides you the detail about data set, especially what type of data each column contains, and how many unique null values that you have. So run this. Then let me quickly, okay, it's fine. Let me quickly delete everything and I'll start over. So just everything is clean now. So I will rerun from the beginning. This is run. This is run. This is run. This is run. Okay. And we have the data loaded. We have the shape printed, and we have the housing, the bottom printed, and now the detail of the data set is printed here. So the ocean proximity, here we are basically just what we're doing is the last attribute is ocean proximity. We are accessing just the last values, the column. So from these columns, just we are accessing this column data, the data on this particular column. And what we're doing here is we want to inspect the last column. So this is part of the data exploration process, and we are exploring the data. And just let me comment this line out, and taking the value counts of how many distinct values are there in the corresponding value count. So here we have, so this is one value, the second value, the third value, the fourth value, and the fifth value. So the number of distinct values in this particular column are 5, and each of them have this many corresponding numbers. For the first value, we have this many this many rows with this value, this many rows having this value, this many rows having this value. So just a number of rows containing each of these values are printed like this. And similarly, for the other one, just I simply picked population, which is, now these are the columns, as you see, longitude, latitude, longitude, latitude. These are the data, the columns on the data set. So I picked population, right? Population, and then just let's print the population, and then just you will see. Since this value is a numeric value, we have so many numeric value we cannot see. So just there is a continuation. So the distinct values are not that. The top number of similar values are 25 rows, 25 rows having this many. So this is how you can count values in the entire data set within a particular column. So you can play with this. So I can print both of them by running print. The reason why I am using print here, is because if I don't use print, the last execution overrides everything that was written. And just let me quickly show you. Let me copy it down here, and for comparison, you will see the reason why I used here. So just print is basically to see if it keeps them in order without print. You see, so you only have, although we have the two lines one after the other, the output only has this output. This output is the output of the second line. The first line, since we don't have print, it doesn't print one after the other. It basically just overwrites the output. But here, since we have print, both outputs are printed after. So this is the reason why I used print. And the other thing is, on the data frame, this method describe data frame dot describe gives you a statistical description. Summary description of the data in the data frame, right? So describe on a data frame gives you a statistical description. And in a statistical description, for numerical values, you have mean, median, and for categorical values, you have mode, right? So just let's see the statistical description. And the statistical description is by column, description of the data. In each column. So one column is taken care. If we are calculating mean, median, mode, so the mean, median, and quartiles as well. So just every column will be taken. So just let's run and show you what I mean. And so here, everything is calculated. So for longitude, for latitude, for housing, for each, we have this corresponding. How many of each we have? The count tells you how many of them are not null in this statistical description of the data set. And the mean gives you the mean value of the particular. For example, the longitude data, just you cross-sectionally take the data and you cross-sectionally take the data and calculate the mean. And again, the standard deviation is calculated for each particular column. For each particular column, standard deviation. The minimum value, the 25th quartile. This is the quartile value. The 25th, the first quartile. Quartiles are data points that divide your data into 4 quarters. You will have the first quartile, which shows the 25th in ascending order. In ascending order, the value that basically shows or the 25th percentile, or the cutoff point for your data for the first 1/4 of the record. And the second one is the second quartile is a median, which means the middle point, the middle data point of your data set. And the 75th percentile, or the quartile 3, is the 1/3 cutoff point of your data. And finally, the maximum. So these are just in statistics, you have these 5 numbers: the minimum, 1, 2, 3, 4, 5. The mean, the median, the max, quartile 1 and quartile 3 are the key 5 number values. But we also have the mean and the standard deviation. I said the minimum, the median, the maximum, and the quartile 1 and quartile 3 are the 5 numbers that describe your data from distribution perspective. But the mean, also the average value, and the measure of dispersity, which is a standard deviation, gives you some idea how dispersed the data, what the mean of the data is. As you can see, the mean is here, 119.56. So the longitude, just at sometimes the data point, or like just a calculation, may not give a sense, but you would have to live with it. You have to have some domain expertise to make sense of the statistical measures, especially the measures of central tendency. Some of the values may not make sense. In any case, the method described gives you a summary of your data set by columns, and use just you might hear me saying column as feature. Okay, a column is also referred as feature, a feature of the data set. So we have 10 features or 10 columns here in the data set. And the following code here enables us to create just a folder to store some of our uh, uh, plots or graphs that we are going to plot. So this is end-to-end project. The folder name is image and then end-to-end project. Where do you find these folders? Since I have run this code once, I will show you where exactly this folder is created. Just here you have on the left navigation, you have a folder which says files, and then click on that, and you will see the data sets, the image, the sample data. The sample data will be available, but in the data set, since we run the code here, we have the housing data in CSV or comma separated value format that we downloaded earlier, right? Just when we ran this line, then we wrote the data here. Okay, the data under data set, housing, TGC. This is the zipped data in here, but we wrote it and then just so here we have this data set located at datasets in housing and then CSV. So this is where we have the data set. Okay. And so we are URL, retrieve URL, and then just this was where we wanted the URL retrieval process to write the data into. This is the output location. So the first line, the output location under dataset is the first resulted in here, right? So it is resulted in here. So we wrote it here, and then just we opened from where we wrote it using this line, and then just which is housing as a housing tarball, and then we extract it as a data set, extract the data set, and finally we read the data set as this guy, and we return the method. So this is where we wrote the data set, and the datasets folder contains a data set, and the image contains the output of this execution, right? So here we have this method is used right here, and then we will be writing our data, our image, but just so the image you can take a look at it. So I'm executing this line. So since it is a method, it doesn't show any output. Now here, what we are going to do is, if you remember from our matplot discussion last week, I said that matplot is an important, powerful package that enables you to plot your data. And we are going to plot our data here. We're going to plot our data, and we will be plotting everything, all the columns as histogram. So the housing data set is getting plotted as a histogram. And when we create a histogram, you will see the result. And we are setting this up, the size, the font size, the axis to have labels and title size. And then, so just we are setting the plot, and finally, we are providing the housing data as histogram, on the plot that we that's set up here, and saving the 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 plot right here. And because this is a method that we are using to save the plots as histogram plots, and we are showing the code here, the plot right here. So let me run this, and you will see the output. So it's basically just creating histograms for every column. For every column, we are creating a histogram. This basically gives you an opportunity to see, to inspect your data distribution, distribution. As you can see, the longitude is distributed just like this, and the latitude looks like the housing median age, the age of the housing is plotted like this. These are histograms, and for each histogram, we said the beans to be 50, right? The beans to be 50. So just we used, you can check what beans mean, and the total rooms, each attribute got uh, uh, but one attribute is not plotted, which is like if you see 1, 2, 3, and then 1, 2, 3, 3 by 3, we have only 9 attributes, or 9 of the columns were considered. The reason why the other attribute is not plotted is because the data set, the data type in that particular column is not numeric. So just let me go back here. In here, only out of, we have 10, we said that we have 10 columns. Out of these 10 columns, we have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9 of them numerical values. The other, the 10th one, which is ocean proximity, is a categorical value. So this categorical value is not going to be either included in the statistical analysis, which requires statistical description, which requires numerical values, or graph in a graph, unless we approach it histogram. For a histogram, it's not going to be considered. That's the reason why. Now, so the next step, so far what we did is we got the data, right? We got the data, and the second step is we checked what data, the data detail, the data detail. Part of it is basically just trying to visualize the data. So this is just a sample process. You would have to use different types of techniques to visualize your data. The only technique that we used here is using histograms, using histograms for numerical value. Some probably you may have to use pie chart for your pie chart for your data set. Let me quickly, if we can say, if we can create a pie chart right here. Okay, we have okay. And here and I don't see all this. I don't need all this. I'm simply trying, and let's see. Okay, I might need housing. of this column. The ocean proximity. Ocean proximity. Just picking the categorical value. And here, let's see. If it works. Okay. Yeah, something wrong. Just but you would have to, you can check how you can draw a pie chart here. Yeah. Chart for categorical. I don't want to spend time to figure out the categorical column. Ocean proximity. Okay, for this categorical column, ocean proximity, you can draw pie chart. Any case, so just so the what we are after here is what are the steps that you need. First, you get the data. Second, you basically just try to inspect the data. How many? Just check the statistical description of the data. What type of data type it data types each column contains, and then visualize, create graphs, histograms, line charts, all kinds of different charts that you can draw and understand your data set. So this histogram is not the only one, but it could involve some time series pattern in your data. So time may be part of your data set. If there is time over time, how does the data flow? So those kind of relationships can be created, and visual representations of those kind of relationships can be inspected. And the next step is, once you identify that, you may have to split your data, right? Split your data into testing and training. So before just getting into the actual training process. Now, for training, we have this method, a method used to I'm sorry, I was having some network glitch, network issue. It's not only in Ethiopia that you have a network issue. We also have here. Okay, let me share again. I'm not sure if the recording is going on. Okay, the recording is going on. Okay. Okay, quickly share. And here we are. Okay, so I was explaining this method. Let me see. Okay, so I was explaining this method. This method helps you to create a randomly selected test set. When you select a test set, you don't basically just keep your data set in a continuous order, like just you have to randomly select, but you have to set the ratio. In any case, you can go through this method detail, but I will quickly walk you through. So the shuffled indexes means index that basically gives you a permutation given the data. So this is the input data, and it calculates the length of the input data, the number of rows in the input data. And from the number of rows in the input data, we are randomly selecting numbers, the indexes, just indexes of this data set, randomly creating index from this data set and just collecting them here. Now, in shuffled indices, we will see where we are going to use. The test set size is calculated as the total number of records in the data, the length, the number of rows in the data, times the test ratio. The test ratio could be 20%, 25%, or 30%, but that number should be provided as a decimal point, either if it's 30%, 0.3, 25%, 0.25, 20%, 0.2. So this ratio in the data. So then we have the test set size. Using this test set size, I calculate, we basically just grab the test indices. The shuffled indices give you like just randomly organized array of numbers, uh, uh, having the same number of records as the number of rows you have. So from that, just this is the area that we discussed last time. Basically taking the last portion of the data as test set size, and the first portion of the shuffling index, which is as the training indices. The test indices, we are cutting using the test size at the last portion. If it is 20%, you have this 20 calculated here, and the last 20% of the total data set, you will know just where the cutoff point is. In any case, and finally, you have the test indices, the training indices. And in Python, you grab using indices like this, iLog of the data, and the given indices will basically help you grab the training indices, and similarly the test indices. From arrays, we are basically chopping numbers. Just take this, kind of, and on the other thing is here, this Python method returns two values. If you have used Python, I think you understand this. In Python, you can return multiple values from a method. But this in most recent versions of C#, it is possible. Some just that you can return tuples, right? Tuples. So Python has supported that approach as returning multiple values or tuples from a single method code, just like this. So this comma shows this is the first return. As you accept that as you when you use this method, you would have to expect two values to be returned from the method. And the first value is for the training data set, and the second value is for the testing data set, just in the order as this return method is written. So right here, so we are using this method right here, and the data is housing, right? And the test ratio is 0.2, which means 20% of the data. And then just the first return value of the method is the training set, and the second return value of the method is a testing set, right? So now let's run this and see what happens. There we go. So now we run the method, but just okay. We run the method, and the training set and the testing set are captured as output variables, and we checked the second. This line checks the length of the training data set. How many data do we have here? How many data do we have here? So this many. 16,512, which is 80% of the data is this much. And here about 4,128. This is 20% of the data. The sum of these two rows, the numbers will give you the total number of the records. Now, the other thing is, in most of the time, you will see this kind of setting. Seed is equal to 42. So this number 42 is some magic number, right? So there are some explanations that I'm not going into the details, but setting a seed makes you just your code to rerun multiple times without changing the output. The only thing that would change is here, since we are randomizing these values, the input, the test data set and the training data set could change. They could change. But we are basically trying to set that change not to happen. And since algorithms get tweaked, the other source of change is get tweaked. Some versions may get updated downstream in the code, so that would make the randomization not to be stable for a given time. In any case, so this is a magic number that we usually set so that the result of our execution remains the same. You can read through the details. And so another thing is like just a cyclic redundancy check. We have these methods. And using these cyclic redundancy checks, we can also split the data into like test and training with indexes. So with indexes. So these methods in the housing with ID reset with reset index, we have this, and the training set and the testing set are again we had training set and testing set, right? Train set, test set, and again just we used a different method to create the test and training set, but we are splitting the data with hash value. This hash code is used. You can use either of the methods, but for your understanding. But as I mentioned earlier, for example, scikit-learn, the machine learning library that we're using right here, has got a method to split your data into training and test by simply providing the yeah, there you go. Here it is. Train test split. This is another method that you have. Just we are importing from the model selection sklearn, and this method is right here. You provide the test, the actual data to split the test size by percentage 0.2 and the randomization 42. So this line basically just does everything that you wanted to do, but we wrote custom methods right here to split, just to avoid randomization, and also right here to split. But these are the two are shuffling and splitting data. We did here again. Split data with ID hash we used here, but all what we did was to basically just repeat what scikit-learn provides us. Most other, I mean, almost all frameworks give you this method. So the training test split method is available. So you don't necessarily need to write such code, but it is good to understand the internal details of how the testing and the training data gets split. We don't basically say, when we say 25% or 20% or 30% of the data to be used for testing, we are not saying that just cut at 75%, let's say for 25% testing purpose, cut at 25%, and then just keep this the 75% of the data for training, the 25% of the data for testing. It's not like that. You randomize the selection. You randomize your selection so that just the selection is not biased to a certain order. Again, the training and test split in scikit-learn internally does that for you. And here we got the training and testing set. And now just and just to check again the links of train set. Train set is the same as we saw already, and again the test set the test set is also the same, which is so. Now we have these two sets, to training and testing set, and how many null values in the testing set? The total in total bedrooms column. So in the total bedrooms column, we have 44 nulls here, 44 nulls here. Here, total bedrooms, you see, total bedrooms, we have this much. And if you see the data, you can see some difference in here. The count tells you the unique values in the data set. Every longitude, latitude has got all the data sets. And the housing median age is all available. The total rooms column has all available. But here in the total bedrooms, you have some missing values, while all the others have 20,640, but this guy has got 20,433, which means some of the values are missing here. Some of the values are missing here. So that's what we can see. So this approach gives you a way to check each so much. Yeah. So this the total in the test. This is only in the test set, but just if we see in the housing set, how many of them are null, we can see here. The housing has got 207 nulls in it. 207 nulls in it. Out of these 207, we have 44 of them in the testing. So this housing is a full data set. The housing is a full data set, and the 25% of the data, which is 4,128 rows, have 44 of them in the housing, in the total bedroom column being null. Then to find the probability that a random sample of 1,000 people contains less than 48.5% female or more than 53.5% female, when the population's female ratio is 51%, we use binomial distribution. The coefficient of distribution method for binomial distribution gives us the probability of the number of females will equal or less than the given value. So if you see here, out of 107, how much percentage of the data is 44? You can calculate. But we took 20% of the data. And how much is 20% of this total data? How much is 20% of this total data? It's a matter of multiplying this by 0.2, right? 0.2. 0.2, this is going to be 41.4, which is about close to 44. So the randomization helped us to make the number of nulls not to be the number of nulls to be, just equally distributed across the data. And the binomial from we have another package here, this package is Sci-Fi Statistics. Sci-Fi Statistics is again another popular package which helps you to calculate the scientific calculations in statistics for scientific calculations. And binomial is from the statistical namespace, and we have, let's say, sample size of these. This is basically just trying to do what's needed, and probability of too large is equal to 1 minus binomial. So 0.10. So if you prefer simulation over maths, here is how you could get the roughly the small result. And this and here we have again, just basically we're cutting the numbers into smaller size. Do you have any questions so far? You can write it and I will read and we can answer before I go far here. Questions? Do you have any questions? I'm going to check the chat. It isn't. Oh. I'm sharing right now, right? Can you give me feedback? I see some comments. So you see the code that I'm sharing, right? Okay, perfect. Thank you. Yeah, I got the answer. Oh, but not enough visible. Okay. Let me make it bigger. Sorry. Sorry about that. Okay. How about now? The size of the screen is too much now. Okay, let me make it. Oh no. Yeah, let me make it a little manageable. Maybe this is not needed here. Okay. Okay, fine. I think just we have this managed here. Sorry about that. I think, yeah. So now, like, just let's create. Oh, sorry, this doesn't work because I didn't run the previous code. So I have to run this column, this code, income categorical, in categorical order, and then income value count, sort index, and then just it will plot the graph. So here it is. So income category, number of districts in the housing income categorical bar plot. So just we are basically saving this. So we are saving this plot as this if you need. So before showing it, you have to save it. This line is not required to show the graph. This line is required to save the graph. This line is required to save the graph, not to show. The show is the last line, and we have this income category created, in the income category is used. So income category, we are basically just we are creating a new feature. The income category, income cat, doesn't exist in the dataset. In the dataset, we didn't exist initially. So here are the columns that we had. For the dataset. Let me go to the list. So these are the columns: the longitude, latitude, housing median age, but there is a median income, but not house income category. Income underscore cat doesn't exist. So we are engineering. We are creating a new feature. This is called feature engineering. We are creating a new feature from existing feature, which is called feature engineering. Feature engineering is important for you to create some new features and identify some sort of pattern that you could be able to use. So that's what we did here. Yeah, so what we did here is we created an income category here by cutting the housing median income into beans. Bean 0. Like just at 0.1 to 1.5, 1.5 at 3.0, at 4.5, at 6.0, and if there is no information, then just we exclude, we create that, and then 1, 2, 3, 4, 5 are labeled here, right? And then it excludes the last one. Now we have 1, 2, 3, 4, 5. In the median income, having 0.8 is the first one, 1.5 is the second one, 3.0. So now we are creating a bar chart, right? We are plotting a bar chart on the new categorical column, the new categorical column that we created, the new column that we created, right? Okay. So income category identified. So this is called feature engineering. And another thing is here, the stratified shuffle split is another way to shuffle our data and using the training and testing index, we can shuffle the data here and there, and we can split the data to a training and testing set. A training and testing set, strat split to be 0, then just if the strat split is not given, we have, and so we are training and test split using strat split. And now stratified training set and stratified testing set are created here. They are created here, and then just the income category value count divided by the stratified test set. The length of the stratified test set is here by income category, how distributed the data set is, right? Income category of one of the values, like just the index is given here, 3. If you remember here, we split them, we named the values as 1, 2, 3, 4, 5, right? And then the distribution is for 1 we have 0.0399, which is exactly the value that we can see under here, right? Under here, the percentage, basically just the percentage distribution of the data, and the highest is for value index 3, and then just let's see what 3 is as compared to the other. 3 is 0.35, but the next value is 0.31, which is 2. So the histogram, 3 is the highest and 2 is the next, and 4 is so that's how you would see, basically you would visualize your data set. In addition to creating a visual representation of your data, you can also see use other techniques to check. Income categorical proportion is, now we have this method written. Instead of just doing this as a one-off, this method is created as a method here. As this is nothing but just nothing but just the same thing represented here. The test strat, you see, this is the value, income, value counts, and lengths of the same data. So this is the same, but just the input is different. You can use for, now we wanted to use overall percentage, stratified percentage, random percentage for the housing, for stratified test set, for test set. So just this is a way of reusing the same method instead of rewriting this long line here in the as you see. Instead of writing the long line, just package it into a method and reuse it multiple times. And to compare proportions, we have these. So this line compares proportion, and now let's see the outcome here. This how income category 1, 2, 3, 4, 5, and the overall percentage, the stratified percentage, the random percent, stratified percent error percent, and random error percent. Okay. If there is any question, okay, good. No question so far. Ask if you have a question. So here we are also dropping income for set in stratified test, stratified set, drop income category. Now we are dropping it, and let's see what happens. And we have the housing, and then the housing data as stratified training set copy, and let's plot this. Now this is a scatter plot, and this scatter plot simply takes from the housing dataset the longitude and latitude, the X and Y value as longitude and latitude, and we are creating a grid line. The grid is this, right? These are the grid, and the kind of the plot is scatter. The kind of the plot is scatter. Here we are saving the graph. As I said, the save fig is a method in here which simply saves the visual to it's not required. So shows the latitude by longitude. You see, this looks like a certain picture. Remember, this data is from California. It is from California, and let's quickly see the map of USA. These states, and then I will show you where exactly California is. Right, so California is right here. You see, California is right here, and the graph that, since our data is kind of real data, the longitude latitude is the GPS location of a point, right? A point. So it shows that pattern. Okay, this point, each point is represented by pair of values, the longitude, latitude, and each point shows this one, right? So here in California. Can you please remove the notification message at the bottom of your screen? Okay, which message? Oh, okay. Okay, thank you. Can I? I don't think I can. Okay, let's see. Unfortunately, I can't. Okay, let me quickly save and okay, probably that's the reason why. It is telling me somebody updated it somewhere. Okay. Yeah, overwrite. Okay. This should. Perfect. I think the notification should go away. Perfect. Okay. Now, thank you. And can you please remove when we split our, okay, there is a question here. When we split our data set, does data set size matter? The training and test set portion, depending on portion departing or constant through any size? Well, I think just this is a choice that you can make. The most common testing and training split are between 0.3, 0.7, and 0.2, 0.8, which is you can have as you can even have like just for, like if you have a good size data, you can have as your data size increases, you can increase the testing portion. You are connected to GPU runtime, but not utilizing the GPU. Okay, so let me change my. But if I change, okay, fine. So it might require me to rerun. Like we will see by running one. Let's see run. Let's run this one. Yeah, so I have to rerun everything up until this point. Or I can run all. I didn't want to do that, but running all is not good. It will take forever. It will block us. Yeah, because yeah, so the testing and training is if you have larger size data, you can have up to 30% of your data, even 35, 40% of your data for testing. But if you are a smaller data set, but if you have large data set, it is advisable to use other techniques. For example, cross validation, which means you can split your data set into n folders, whereby you can validate your data, your model as you train it, and then finally utilize a small portion of the real representation of I mean, just a representation of the reality to test your method, to test your model. Okay. I shouldn't. Okay. So we have this. We don't need to rerun this because we are not. So there are multiple methods here. Okay. The shuffle split, they will be overwritten. We need this. And this wasn't used to split. And we can use this method, which is a scikit approach of test. And this simply to check. You don't necessarily to rerun them because we don't need the values later. And how about this? This is simply to check, but we might need the scikit. I mean the scipy code or library. Again, we have this already set. and income. We are graphing. Okay, this will fail because I didn't run this one. I ran this one. Okay, somewhere we don't have. What are we missing? Error, pins. Let's see. Because we didn't run here. Okay, somewhere we missed running, importing. Okay, probably this is the reason why the import is not there. So this is why. Here we have, and where are the other? Okay, and here we should have successful run and ensure really should work here, and this should work here, and okay, this is the method. And we checked this now. So discover and visualize data to gain insights. So visualizing geographical data, that's where we were. That's where we were. And so now, and as I showed you, like just these maps, just like the US map of California. And then again, just a little different, but better visualization by showing the relative importance of, and then just because we gave alpha to be 0.2. And here, this have another scatter plot of the housing price, the housing, just house by the housing price, right? The median house value that you see here shows you, and as it is, the blue shows you the lowest, and it goes to green, and it goes to red, and more red, right? And just this basically tells you something. Your data or the data that we are using tells you something. If you see the distribution of the data on the upper left side, they are almost blue. And just as you can see on the edge here, most houses are kind of expensive. The median house value is higher as the color gets more reddish, right? And this is a very good representation of the reality on the ground. The reality on the ground in the United States, wherever you have, if you have a house close to the coast, then just your house value is so great. Or next to with a good visibility to the coast, with a good visibility to a water source, nature, then this makes that makes your house to have a higher value. And on this side, we have like the Atlantic Ocean, right? The Atlantic Ocean, and just the houses that you have by the coast are kind of expensive. So that's what you see, the reality captured in your data. So this kind helps you to learn more about the data. And okay, I think let me make it a little larger, a little more, and I think this should be enough. Okay. Okay, so the next cell generates the first figure in the. Okay, basically like this is talking about the book, and now you see now we have the California graph embedded into our actual data distribution. You see, so in California we embedded the data. So this data comes from the graph, the California graph, and then just we basically wrote embedded that data into our visual or our graph. So our graph not only has the actual data, but also like just not only have the data, but also the actual map of USA. So this is how you would see. And now the other thing is so we are in the process of basically cleaning data and visualizing the data. So one of the key things that we need to ensure is our data is not dependent, or like the columns are not dependent on each other. The columns are not dependent on each other. What that if the columns are dependent on each other, a change on one column always shows a corresponding change on another column, or a change in one feature always showing a corresponding change in another feature. Okay, so somebody's asking to revisit this. Let me make it a little smaller. And so what we did here is we got the data, our actual data with latitude, longitude, and the population, as well as the median house value used in representing in plotting here. Not only just that, but also we got the map of California, the map of California here, the map of California here from the from the net, and then just we are embedding it. So this shows you the map of California, and also on which the data, the actual data is plotted. Here on the edge, like just on Atlantic Ocean side, like just if your house is an ocean and is of a good size, then just your house would be expensive. So this is how it shows, like these colors show the expense. By then, as the number increases, it means the median house value increases. So this is what is happening. I don't know if that answers your question, Rehiyot. Anyways, so so what we're yes, great. So what we are after is mainly like just to identify whether or not our data has some sort of correlation, and then just we create a correlation matrix for our data set. Correlation matrix is a matrix where you will check every column, every feature of your data set, every feature of your data set. I prefer using feature instead of column, right? Instead of column, because a data point is represented by 10, our data point is represented by 10 features. So every feature is mapped against every other feature, and correlation gets calculated. Correlation, the Pearson's correlation coefficient value gets calculated. And correlation coefficient helps you to check if one value is consistently changing along with another feature. That means you don't need both features in your data set. You have to get rid of just one of them. The way you decide is correlation coefficient can be between zero, no, between -1 and 1, between -1 and 1. Between -1 and -1 means an increase in one feature means a decrease in another feature. A negative value means, and -1 means complete opposite, decrease increase difference. And a positive means as one feature point increases, the other also increases. So that's the positive correlation. And the one means one, just if it is one, always it increases with the same proportion as the other increases. And zero means there is no correlation between the two. So with that, let me run this and see the housing correlation. Okay, so something, the default value of numeric only data frame is deprecated. Okay, so the reason is, okay. Okay. Because there is a categorical value here. Is equal to, let's see. So let's see how we can deselect. And we wanted to exclude what was a column. Okay. I think. Okay. So we will see. We will start from here next week. So looking at correlation, I will write this method to deselect the column, since we are on the time. It's because of the categorical value that we are not. In the past, this method used to support, but everything, and then just deselecting categorical values. But now there seems to be a change in the library, the pandas data frame library, where this method, correlation, does not automatically deselect categorical values. That's what this message tells us. The default value of numeric only in data frame correlation is deprecated in a future version. So it's already happened, right? So it will default to false. Okay, maybe we can do this. Numeric only is equal to true. Let's see. Numeric only true, and let's do it. Yes, did it? Okay, correlation matrix. Okay, I think it did. And now let's run. Yeah, but I want to see the entire matrix. So this is only selecting one. Yes, so this is what you see, like longitude with longitude, longitude with latitude. This, like, just diagonally, if you go, you see 1, 1, 1, 1, 1, 1, right? 1 for all of them. But you can take one column, one feature from here, and then check their corresponding relationship with another feature. And if you find number that is approximately close to -1 or close to 1, that means that value is potential number to get removed. For example, total bedrooms and the households, the number of households, you see, they are kind of just going together, and the population also going together. So just 0.97. Obviously, if you have more number of bedrooms, that means there will be more people living in your house. Households means the number of, right? The number of people in your room. In any case, let's stop right here. And we will continue from, we will repeat from here, and we will revise whatever is needed. And we will discuss about linear regression, logistic regression, and other algorithms. And whoever, if you have anyone who was waiting this key discussion about the actual machine learning process, call them, let them join next week. And thank you very much for your time. And if there is any question, I can address them. Okay. Any question? Why we use stratified shuffle, test split rather than random? Oh, there are just, you can use random train test split and stratified. Sometimes you may have to use a stratified approach depending upon the domain that you wanna consider in your stratified sampling technique. Some features may be important to stratify your data into than just randomly, blindly and randomly splitting your data. And another is in pre-processing data, we want to change from continuous to categorical. Can we change female into and male? You can change, but you have to be careful not to do any mathematical operation on those data. And sometimes, yeah, like some algorithms would require you to change categorical data into numerical data. We will see. We have an example in this data set. We have an example. We will see. But the critical aspect of it is not to do any mathematical or statistical operation on those data points. Any other is after we draw pictures like histogram, bar charts, and so on, how can we understand and make an analysis of them? From your example, you draw a histogram to the attributes, which one is in normal distribution and which one is not. Yes, I think just that's something that you would have to visualize, and there could be some sort of pattern that you would see. We will revisit the diagrams next week, and we will see. The other question is, what do you mean by representing both categorical and numerical data column in two different graphs, one by pie chart and another by histogram? Because histogram doesn't support categorical data unless you shift the numbers in the name, right? Histogram requires a continuous data point, right? Just you have to split your data into bins so that you can have histograms, but you can use bar chart or pie chart for categorical data. That's the reason why we didn't use histogram for the categorical. One of the 10 attributes or the 10 features of the data was ocean proximity. So the ocean proximity was categorical, and that wasn't part of our histogram visualization. And I'm unable to open the recordings of the 4 week. Oh, good question. Good question for all of you. The 4th week opens. I double checked. I sent the link. Check the latest email. The link in the latest email. The password changed, but I changed the link in the latest email. So check the latest email. The link in the latest email, please. I will also send a note of that along with this record. So you don't need to be part of. You don't have to have access to anything or be part of any group. When I send email, I send email just making you all as a blind copy under a blind copy. The two email that you see at the top is not a distribution list. It is my company email. So it's just a single email. You are not just anybody is not part of any group. So other question is, I'm unable to open the recording of force. Fine. So that answered for the record request, Microsoft account, please, or I will be updating. I will be sending when I send this recording, I will make sure that you get the latest link. Day 3 also not open, not for me, doctor. Yeah, so I think just please check with your friends when you have this kind of issues. Check with your friends if they still have the similar issue. But just for day 3, maybe McQuarrie, you may be the only one. But for day 4, I understand it wasn't downloadable. I tried to fix it, and just when I fixed it, yeah, it wasn't downloadable. I fixed it, not downloadable, and the link is in the latest email. Okay, any resource is not get weak resource. You add my email. I don't know. So I already have registered people added. So even I couldn't open the first class. it says the password is wrong. Please double check. Yeah, thank you very much. Thanks everyone. Enjoy your day, and yeah, I will double check. Ababayo, I will check your email if you are added. Abaino, sorry. Yeah. Okay. Okay. Thank you. Thanks everyone. Yeah, send me an email. I can't figure out what your email address is from here. Okay. I got your email address, Ramla. Okay, anybody just having issue, please reach out to your campus coordinator. Please reach out to your college coordinator, and they will send me. If you are not, if you are having issue, it's very difficult for me to deal with every individual. Like you are to them. That's the reason why we have college coordinators. Reach out to your college coordinators and work with them, so that I can help you. Help me to help you. Okay, I will do. I will send the today's notebook. I will send as usual. Okay, and thank you very much. And